That happens every now and then. I have yet to figure out whether it's a problem on my end or with GoToMeeting. All right, let's see. We had a vertical hyperbola. And I believe my question, where was our center? It was at minus 1, 0?
0.
So there's the center. And I'm going to draw a box. And let's see, A was 1. What was the rest of it? B was 3.
A was 1, B was 3, C was square root of 10.
Okay. So is my box like that or like this?
The second one, because it's vertical. Right?
No, the first one. Because it is vertical, but A is a 1. A is smaller than B. In other words, the vertical is the A measurement. So my box needs to go up to 1 and over to 2. Hold on, let me dimension this thing correct. You see why? Over to 2, yeah, let's see, this is minus 1, and B is 3. So this thing goes to minus 4 over here, and to 2 on this side. And my hyperbola is going to look like this, something like that. So it's a vertical hyperbola, but the box, the dimension for A is 1, not remember that with a hyperbola, A does not have to be bigger than B. They can be anything. This box can be either shape that I drew, or it could be square. But there's no requirement that A be greater than B. The only requirement is that A be measured along the major transverse axis, which is right there. That's the major transverse axis, if I draw a line through it. Okay?
Okay, so...
Hold on one second. Go black for a second. Okay. Okay. Now, let's see. What else do they need here? We need...
vertices and the foci.
Okay. What's the coordinate of the vertex right here and right here?
Negative 1, 2? 1?
You know what? No, it's positive 1.
Yeah.
Because A is the measurement from the center to the edge of the box. And A is 1. So we've got to go up 1 from the x-axis. And down 1.
Oh, so that's how you know where to put the foci?
Well, we're not to the foci yet. The foci, yes, the foci are also measured along the transverse axis. I'll use an X for the foci. Hold it. I'll use a dot. I used an X for the major vertice.
So the vertices are what you do, like, from what A is?
From the center, yes. The vertices are a distance from the center, always. Sometimes it's measured vertically, sometimes it's measured horizontally, but A is the distance from the center to the vertice.
So does it always stay with Y and then X? You know what I'm saying?
Yeah, in other words, X stays the same here and Y changes. So what are the coordinates of that foci right there? The X is minus 1, but what is the Y?
Probably 2.
Square root of 10, is that what you said?
Yeah.
Okay. And this foci is minus 1 minus square root of 10. And that completes that problem. The other thing they could ask is the equations of the diagonals. Because the diagonals are important here. You'll notice that I didn't draw this thing very good. If I draw diagonals, this hyperbola is supposed to be asymptotic with these diagonals. And I didn't even come close to accomplishing that with my drawing. So let me change it. I think that also has a wide eccentricity. In other words, with hyperbolas, eccentricity is going to be a measurement of how flat the hyperbolas are. All right, let's go to the next problem.
Let's not do those ones. I just have a question on, since we don't have much time,
Okay.
just have a question on, so like when you're doing a parabola, or no, not a parabola, yeah, parabola. So the equation would be the like 4p, and then the y minus k equals x minus h squared. I don't know how to find the p.
Yes. Okay. So let's make up an equation. Let's say that I have 2 times y minus 3 equals x minus 5 squared. Okay? So we know where our vertex of our parabola is. 5, 3, right there. We know it's a vertical parabola because it's of the form y equal x squared, not x equal y squared. I know that it opens up. So my parabola looks like that, so I want to know where that point is. Well, 4p is equal to 2. So what is p equal to?
2.
If 4p, in other words, equate 4p with whatever the coefficient is over here, and that would give you p is 1/2. So this distance between the vertex and the focus is 1/2 on the equation I just made up. Now, they can make it a little more complicated if they try to fool you and put this 2. Notice that I could put that 2 over here, and it's the same equation. So if I gave you this and said, what is the focus?
You'd multiply the other side.
Yeah, in other words, get rid of this denominator and make it that coefficient, and then you can equate 4p to whatever this coefficient is. Or, if the 2 is over here like that, then I would need to divide both sides by 2, making this coefficient 1/2. Now I would say 4p equals 1/2, therefore p equals 1/8. So manipulate your equation around to take whatever, if the coefficient is next to this term over here, do whatever you have to get it over here. And then equate it to 4p. And same thing with horizontal ones. In other words, if you have a horizontal parabola, then the 4p goes with the x. And this side is y minus k squared.
How do you know if it's horizontal or vertical?
Well, notice this is of the format x equal y squared. This is of the format y equals x squared. So y equals x squared, the way I remember it, is y equal x squared was the first place you ever learned about parabolas, right? And they were always the vertical ones, either that way or that way. So if I see a y equal x squared, I know it's a vertical parabola, even if there's all kinds of other stuff with it. In other words, if you give me a big long polynomial and it's got just a y in it, but there's an x squared, I know it's a vertical parabola. If it's got just an x in it, but there's a y squared somewhere, then it's a horizontal parabola.
Okay.
But the 4p always goes with the variable that is not being squared. And that's another way I remember this exotic form of it. In other words, you remember the vertex format for the parabola is this. Right?
Right.
Well, that's not that much different from this. It's pretty close. Notice if I move my k on the other side, it goes with the y minus k. And the only difference is here the a is next to the x squared term, whereas over here the 4p is next to the y term. So if I divided both sides by a, then I could say that 4p equals 1 over a. If you're looking at a parabola in vertex format, then that's what the equation would be, is 4p equals 1 over a. But you could do what I was suggesting, move whatever a is, get it to in front of the y. In other words, I don't have to do much to get vertex format into this format. If here's vertex format, move the k over, divide by a, and I've got conic section parabola format. And so now it's easy to see where 4p is equal to 1 over a. Don't really like the fact that they introduce a new format. I don't see the purpose of it, and not all schools do. Colorado Springs schools don't use the 4p format. They use the vertex format for conic sections also. They just tell you that 4p equals 1 over a. And then you solve for p, given a certain a.
Okay.
Okay. All right. You good to go?
Yep, I think so. Thank you.
Okay. Jade, can you ask your mom if she received my envoys?
Yeah, sure.
Okay. I've emailed her a couple of them, and I haven't had any response. So if you could...
What email are you sending him to?
C. Mansour at... Hold on a moment. Let me... Maybe she's not...
I just want to make sure you have the right email.
Yeah, I want to make sure too. C. Mansour at janssenpump.com?
Yeah.
Is that the correct one?
Yeah.
Okay, that's where I've been sending them. I had originally sent one that she paid back in October 20th, but the balance is now going to be $207. So
Okay.
I don't usually carry big balances like that. So.
Yeah, okay. I'll tell
All
her
right,
to
I
pay you.
appreciate it. Thank you. I'll talk to you
No
next
problem.
time. If I don't talk to you before Christmas, have a good Christmas, and probably talk to you after the New Year.
All right, thanks. You too.
Bye-bye.